The word ITER is Latin for the way. You'll agree the name points us to the importance of the project. Introducing ITER, the way forward for a more sustainable and reliable energy source. That's right, this groundbreaking project is set to deliver unlimited energy by 2024. But what is ITER, and how does it work? Don't worry, we've got all the details covered in today's video. Get ready to say goodbye to the reliance on fossil fuels and unstable production from wind turbines to a bright, limitless future with ITER. Join me in this video as we dive into all the details of the highly anticipated ITER project. What is ITER all about? ITER stands for the International Thermonuclear Experimental Reactor. Basically, ITER is an international fusion energy experiment being conducted by the collaboration of over 35 nations in the world. The aim is to build the world's largest tokamak, which is a magnetic fusion device that is large enough to power our world the same way the sun and stars are powered. And the best part? The fusion energy source is also carbon-free, which means that it'll be able to provide unlimited energy while helping keep the Earth green. Tell me, what could be better than that? ITER's a huge shot at advancing our world. If the project sails through, not only would sustainable energy supply be assured, but it would pave the way for more advanced fusion power plants in the future. This could be really big. Some of the specific objectives of the project are to 1. Generating a fusion plasma with 10 times the thermal power of the injected energy. 2. Maintaining a fusion pulse for a record-breaking 8 minutes. 3. Developing the technologies and processes needed for a fusion power station. 4. Testing tritium breeding concepts. 5. Exploring the burning plasma state. ITER Fusion Energy Project, from concept to reality. The journey to fusion energy dominance has been a long one. It all started back in 1985, with a mission to prove that fusion could be a viable energy source. Fast forward to 1992, and several parties joined forces to bring the ITER project to life. In 2006, 20 billion euros was approved to bring the project to fruition over the next decade. Since then, it's been a roller coaster ride of construction, site preparation, the heart of ITER, the tokamak building, and component assembly and integration. But don't be fooled by the setbacks. ITER is on track to change the energy game and bring us limitless fusion power. Keep watching as we dive into the exciting history of this game-changing project. The fusion energy revolution is coming soon. Following the present timeline, ITER is expected to be functional by 2035. Over 10 million components have been transported, assembled, and integrated from the 7 member countries where they were created and tested. With all these components, the ITER tokamak would be the largest and most powerful fusion device in the world. The project is being built next to the Cadarache facility in southern France. At the moment, the project is funded and run by 7 member parties, namely China, the European Union, India, Japan, Russia, South Korea, and the United States. Construction of the ITER complex in France began in 2013, and assembly of the tokamak started in 2020. With an initial budget of 6 billion euros, this project is shaping up to be the most expensive science experiment of all time, the most complicated engineering project in human history, and one of the most ambitious human collaborations. Despite the high price tag, which is projected to range from 18 to 22 billion euros, the end result could revolutionize the way we power our world. The cutting-edge technology behind the fusion energy revolution. While the ITER machine has lots of components, there are several parts which are central to its organization and structure. The first is the vacuum-sealed vessel in which the plasma is contained. Basically, to produce a massive amount of energy, a small amount of hydrogen gas is injected into a vacuum vessel, which is a larger donut-shaped vacuum chamber. It's twice as large and 15 times as heavy as any previously manufactured vacuum vessel. The breeder blanket is also a key component of the ITER reactor design, since it requires tritium, which has limited terrestrial supply. Through several reactions in the blanket, tritium is produced. There's the magnet system, which makes use of magnetic fields to contain the fusion fuel in plasma form. The magnet system used in the ITER tokamak will be the largest superconducting magnet system ever built. Within the tokamak, though the changing magnetic fields produce a heating effect, there's still the need for external heating. In ITER, there are 3 external heating types: the neutral beam injectors, the ion cyclotron resonance heating, and the electron cyclotron resonance heating. The ITER Cryostat is also a large stainless steel structure surrounding the vacuum vessel and the superconducting magnets, with the purpose of providing a supercool vacuum environment. The divertor is a device within the tokamak that allows for removal of waste and impurities from the plasma while the reactor is operating. With a massive ashtray made of 54 pieces of stainless steel parts that are known as cassettes. The ITER tokamak also has interconnected cooling systems to manage the heat generated during operation. Most of the heat will be removed by a primary water cooling loop. While it may seem as though Project ITER is rather ambitious in its design, the project itself promises to be largely beneficial to our world, as it's predicted that the massive generation of energy through ITER may allow for unlimited supply by 2024. If you found this video informative and educative, please do not forget to give this video a thumbs up and subscribe to this YouTube channel for more content like this.